Second part of 1.5 is talking about what we can assume and what we can't assume and how we can use that to our advantage. The things that we can assume will help us create steps for a problem to figure out our final answer. So we can assume straight lines and angles. If it looks like an angle, it's an angle. If it looks like a straight line, it is a straight line. We can assume collinearity. If it looks like 3 points are all on the same line, they are. And then betweenness. We can assume that if I draw 3 collinear points, I can assume those are collinear first, but I can assume B is between A and C. And it seems very straightforward to say that, but that's something you can assume. There are things that you can't assume. You can't assume congruent segments. If I take 2 segments and I'm going to draw one, and I'm actually going to just copy it and then paste it. Now, you and I both know that those are congruent, but you can't assume it unless if you see a mark on them that says they're congruent. Same with right angles. If I draw a right angle, you can't assume it's a right angle unless if you see that box in the corner. Congruent angles, same idea. I could copy an angle. I could make an angle a duplicate, but I can't call it congruent unless if I actually see a mark or a statement that says it's congruent. And then relative sizes of segments or angles. You can't say one angle is bigger than the other. Even if I draw 2 angles like this, that one of them is going to be clearly bigger, if I start labeling them now as, let's say this one's 60 degrees, but then I label this one as 45, although it's not drawn to scale, the label takes precedence over the scale. Okay, so be careful on what you assume and don't assume. Take a minute, skim over these. We have a picture down here, and glance through these and just answer yes or no. Can I conclude that? And then we'll go over the answer in just a bit. So, is angle ABC a straight angle? That is something you can assume. Is EBC a right angle? I'm going to say no. Now I know for a fact I made this picture to be a right angle. But because there's no mark there, typically you'll see this mark, because there's no mark you can't assume it. ABC are collinear, you can assume collinear. EBD, so we're talking this angle right here, is congruent to DBC. You cannot assume congruency. Same with segments. AB is probably the same as BC, but you cannot assume it. B is between A and C. Absolutely. You can assume that. And BD bisects. Bisecting is the same as saying you couldn't about angles being congruent. You can't assume that. Alright, let's try this example. 1 complementary angle. So I'm going to stop right there. They said complementary angles, which means 2 angles that add up to 90 degrees. So let me draw my right angle. Let me draw that. Okay. Is 6 less than twice the other? Well, here's the other. Whenever you see that other, always call it x. And then let's work off of x. 6 less than means it's minus 6. And then twice the other means you double it. 2 times x. So, they're complementary, which means they add up to 90 degrees. I'm going to combine like terms and work through this as quick as you can, as comfortably as you can solving. And then you divide by 3. When you divide by 3, you get x is 32. The measure of the smaller angle, we know that one's going to be 32. I'm going to plug it back in just to make sure. 2 times 32 minus 6. That one we get to be 58 degrees. So the smaller angle is 32. So now when we look at this one, if AB is perpendicular to BC, remember this symbol right here means 90 degrees. We want to find x. Well, I'm going to do the exact same setup I did before. X squared minus 5x plus 4x is equal to 90 because it's perpendicular, meaning a right angle. When you combine like terms, x squared minus x, I'm going to bring this 90 over the left-hand side because whenever you see x squared, you want it to be equal to 0. Then I'm going to start to factor. I'm going to look for two things that multiply to negative 90 that add to negative 1. You go through, you think of the numbers that multiply to 90, we get 9 and 10. And we want it to add to negative 1, so we do negative 10 and positive 9. We get our two answers, x equals negative 9 and x equals 10. So let me circle those for a second. What we're going to do is we're going to plug both of them back in to make sure they work. Let me plug negative 9 in purple. When I plug in negative 9 squared is 81 minus 5 times negative 9, which gets us 81 plus 45, which is 126. Now I'm going to stop right there. I already see a problem because 126 is bigger than 90 degrees. That one can't work. When I plug in 10, let's do this in red. 4 times 10, 40. X squared is 100 minus 5 times 10. That's 50. So that one works, and it said to find x, so that's our one answer. One of two supplementary angles is 8 more than 3 times the other. Okay, so supplementary angles, let's get arrows on both sides. Got a straight line. Now from somewhere in the middle. Alright. The other, and this one is 8 more than, that's plus, 3 times the other. Well, I know they add up to 180. So we add them up. Combine like terms again. Subtract, so you got 4x equals 172. And then you're going to take 172 and divide by 4. And I'm getting x is 43. So now that I know x is 43, that angle is 43 degrees, we need to find this one. I could do it one of two ways. I could plug in 43 right here, or take 180 and subtract 43, because supplementary means 180 degrees. So 180 minus 43 is 137. So my larger angle is 137 degrees. When you're setting these up, draw a picture. Label one angle as x, then base the other angle off of that one by reading the sentence.